Hi everybody, hope all of you are well. In my last class, I discussed about Bohr's theory of atomic model. Today we will start from merits of Bohr's atomic model. The Bohr's atomic model explains the stability of the atom according to Bohr's theory based on the Planck's quantum theory. An electron cannot lose energy as long as it stays in a particular orbit. Therefore, the question of losing energy continuously and falling into the nucleus does not arise. Next, this theory explains the line spectrum of hydrogen. The most remarkable success of the Bohr's theory is that it provides a satisfactory expression of the hydrogen spectrum. When an atom is subjected to electric discharge or high temperature, an electron in the atom jumps from the ground state to some higher energy level. Okay, that is called excited state. And since the lifetime of the electron in the excited state is short, it is unstable, okay, so it returns back to its ground state, and during such jumps energy is emitted in the form of a photon of light of a definite wavelength or frequency, and the frequency nu of the photon light thus emitted depends upon the energy difference of the two energy levels concerned and is given by the expression that is E2 minus E1 is equal to h nu. E2 is the energy of higher energy level and E1 is the energy of lower energy level, and from here we can write that nu is equal to E2 minus E1 divided by h. H is called Planck constant. So we know that nu is equal to C by lambda. So C by lambda is equal to E2 minus E1 divided by h. So from here we can write that lambda is equal to Hc divided by E2 minus E1. Okay, so corresponding to the frequency of wavelength of each photon emitted, there appears a line in the spectrum. Bohr's theory can explain the line spectrum of hydrogen of one electronic species like He+, lithium 2+, okay, then beryllium 3+, then boron 4+. So it should be one electronic system. Only one electronic system spectrum it can explain. Every line in the spectrum corresponds to a particular transition from higher to lower energy level, and the lines of the Lyman series appears when electrons from higher energy level, that is from N2 is equal to 2 to 3 to 4 to 5 etc., drops to the levels where is N1 is equal to 1, and these lines occurs in the ultraviolet region of electromagnetic spectrum of wavelength near about 2000 angstrom to 3800 angstrom that we have already discussed in my previous class. Okay, so here this one is the ground state N1. So this is the K cell, okay, this is N2, 3, 4, 5, 6, 7. So in case of Lyman series, the higher energy level excited electrons are coming to the ground state. So this is called Lyman series. Okay, and it falls in the ultraviolet region. And when excited electrons drops from higher energy level to the second energy levels, that means N2 is equal to 3, 4, 5, 6. Okay. So this one we are writing here 1 and 2. So here coming to this N2 level. Okay. And this series is called Bohr series. And this series falls in the visible region. Okay. And in the same way, Passon, Beckett, Farn series which occur in the IR region, that is infrared region. The wave number of a spectral line of hydrogen atom may be calculated by using Rydberg equation. We have already discussed what is Rydberg equation. It is nu bar is equal to R into 1 by N1 square minus 1 by N2 square, and the value of the Rydberg constant is 109678 centimeter inverse. Although hydrogen atom has one electron, yet we are getting the huge amount of lines. Okay, so it consists of several spectral lines. Actually, a given sample of hydrogen contains a large number of atoms. If we take only 1 milligram of hydrogen, it contains 6 into 10 to the power 20 atoms. So when electric discharge is passed through the hydrogen gas, then the electrons or atoms, solitary atoms, electrons in the different hydrogen atoms absorbs different amounts of energy and thus excited to the different energy levels. Okay, so in this way, when they will come to the lower energy level, then we will get a several lines or series of lines. Okay, so in general, how many lines will be formed? Okay, there is one formula. That formula is number of lines is equal to n into n plus n minus 1 divided by 2. Now what is n? Here the n is the number of outermost shell. So n is the number of outermost shell. Next we will discuss the defects of Bohr's atomic model. This atomic model fails to explain the spectrum of multi-electronic system. It is valid only for the one electronic system. It fails to explain the splitting of spectral lines under the influence of magnetic field, that is called Zeeman effect, and electric field, that is called Stark effect. Again we will discuss this Zeeman effect and Stark effect. Okay. This atomic model fails to explain the three-dimensional model of atom, and according to Bohr's model of atom, the electrons move along a certain circular path. That means its orbits are two-dimensional. It fails to explain the cause of chemical combination and shapes of the molecules arising out of it, and this atomic model also unable to explain the deBroglie concept of dual nature of matter and as well as Heisenberg's uncertainty principle that we will discuss after this. Okay, it cannot also explain the relative intensity of spectral lines. So hope you can understand the demerits of this Bohr's atomic model. So you have to read the merits as well as demerits of this Bohr's theory. Next we will discuss the deBroglie equation. deBroglie equation. According to deBroglie, all materials, particles in motion possess wave character. If an electron has a wave character, it should have a wavelength. The wavelength lambda is associated with a particular of mass m and velocity v. If we write the relation, then you can understand that is lambda is equal to h by mv. Lambda is the wavelength, h is Planck constant, m is the mass of the particle, and v is the velocity. And h is the Planck constant. Now we have to derive this equation. This equation has been derived by combining of the mass and energy relationship given by Max Planck and the scientist Einstein. Okay. Now consider a photon having energy E. So according to Planck's quantum theory, we can write that Planck's quantum theory, okay, E is equal to h nu. We know that nu is equal to c by lambda, so h c by lambda, and another equation, that is the Einstein equation, that is the mass and energy relation, that is Einstein equation, is E is equal to mc square. So from here we can write that hc by lambda is equal to mc square. So from here we can write that c is cut, so lambda is equal to h by mc. Now if we consider a particle having the velocity v, then we can write that lambda is equal to h by mv. Okay, lambda is equal to h by mv. So that is nothing but the deBroglie wave equation. So by combining these two theories, that is the Planck's theory and Einstein equation, we can easily derive this lambda is equal to h by mv. Now this equation also known as deBroglie equation. This equation, that is lambda is equal to h by mv, is called deBroglie equation. So here we can write also that, h by mv is what? mv is the momentum, that is the we can write here p. So from here we can write that lambda is proportional to 1 by p. Okay, p is the momentum, so thus wavelength of a moving particle is inversely proportional to its momentum. So lambda is inversely proportional to its momentum. Next we will discuss another important theory, that is called Heisenberg's theory. This is called Heisenberg's uncertainty principle. Okay, Heisenberg's uncertainty principle. Now according to this principle, it is impossible to measure simultaneously both the position and momentum of a microscopic particle with absolute accuracy or certainty. Heisenberg uncertainty principle mathematically can be expressed that delta x into delta p, okay, greater than is equal to h by 4 pi. Okay, now we know that delta x is what? Delta is the uncertainty in the position and delta p is the uncertainty in the momentum. So if we write here delta x into delta v into m, okay, greater than is equal to h by 4 pi. Okay, now what is delta v here? Delta v is the uncertainty in the velocity and m is the mass of the particle. So when ordinary light falls on an object of reasonable size, it will be visible and it is possible to calculate the position and velocity accurately or exactly. But if we think about the microscopic particle that is not visible by our eyes, so the situation will be different. Okay, now when light falls, if we think about electron, when light falls on electron of shorter wavelength, it transfers some of its energy to the electron. Therefore the velocity and hence the momentum of the electron changes. So here we cannot simultaneously determine the position and momentum of small moving particles like electron. Okay, next we will discuss the wave mechanical model of atom. To describe the behavior of electron waves, Schrödinger developed a mathematical equation known as Schrödinger wave equation. Okay, this equation is now not in your syllabus, but you have to know it because orbital, that is the three-dimensional region where probability of finding of electron is maximum. This concept came from this equation. The equation is del square psi by del x square plus del square psi by del y square plus del square psi by del z square, okay, plus 8 pi square m by h square, 8 pi square m by h square into e minus b into psi, e minus b into psi is equal to 0. Now here m is the mass of the electron and E is the total energy, okay, of the electron, and V is the potential energy of the electron, and H is called Planck constant, okay, this H, and x, y, z, this x, y, z, these are the Cartesian coordinates specifying direction and distance, and psi is wave function which represents the amplitude of the electron wave. In psi there is two parts, one is real part and another is imaginary part. We can consider psi is equal to a plus ib, that is the complex number, okay. This is the imaginary part and this is the real part. So actually psi has no meaning, okay, but when we consider psi square is psi into psi star. When we multiply the psi by its complex conjugate, then the imaginary part will be vanished, okay. So this is called psi square. Psi square represents the intensity of electrons at any point, that is, it represents the probability of finding electron at different regions in space. It leads to the idea of orbital. An orbital may be defined as a three-dimensional space or region where the probability of finding of electron is maximum. So next we have to know the difference between an orbit and orbital. Orbit is a well-defined circular two-dimensional path around the nucleus in which the electron revolves, but orbital is a region, that is three-dimensional space around the nucleus where probability of finding of electron is maximum. Now orbit is a circular shape, but orbitals may be different shape, like spherical, maybe dumbbell shaped, maybe double dumbbell shaped. So orbital may be like spherical, maybe dumbbell shaped, that we will discuss later, maybe double dumbbell shaped, but orbit is always circular. Later Sommerfeld modified the elliptical orbit also, okay. Now the maximum number of electrons in an orbit, okay, that we will also discuss, that is 2n square. So in orbit maximum number electron will be 2n square. So in case of K cell n is equal to 1, okay, so 2 into 1 square into 2, but in case of L cell n is equal to 2, that means 2 into 2 square, that means 2 into 4 8, okay. In this way we can calculate the maximum number of electron in orbit, but in case of orbital maximum number of electron is 2. That we can also give the proof, okay, that when we will discuss the orbital and its concept, then we will clear it, okay. So today up to this, okay, hope you can understand. If you have any question, you can send the question to your school website query button, okay, and next day we will discuss the numerical problems, okay, on this chapter, that is the structure of atom. Whatever I have discussed up to this, we will discuss numerical problem. So today up to this, thank you.